Good day to everyone who is watching. In our lesson today of functions, we are going to talk about the composite functions. Composite functions, they are just a combination of so many functions. They can be 2, they can be 3, they can be more than that. But here at O level, we normally look at 2 functions to become the composite functions. So our example 1, if f of x is equal to x squared plus 4 and g of x is equal to x plus 2, find f of g of x, part B, g of f of x, part C, and part D right there. Now, suppose, assuming I have my domain. Remember when we talked about the first lesson, talked about the domain and the range, and in the second lesson, we had some examples of finding domain and then the range. So assuming I'm having my domain here as, let me say, negative 2, negative 1, 0, and then 1. Now I need to get my range there. Then I need to get also another range there. That is, it's going to be the composition of a function which is here and a function which is there, sending elements from here up to that last range there. For example, our part N there, f of g of x. This means that if I need to first get the g of x, then from there I get f of g of x. So this one here is now my g of x, and then that one there is now my f of the g of x. So if I feed this in that function there, which is x plus 4, so that one there is going to be, this is, when I put a negative there, this is going to be 0. When I put a negative there, this is going to be a 1. When I put a 0 there, it's going to be a 2, and then that one is 3. My function of f of x is x squared plus 4. Now, if I get now this, I put there, then I need to get the images there. So when I put there, that's going to be a 4. When I put there, that's going to be a 5. When I put there, that's going to be 8. When I put this in there, that's going to be 9 and then 13. So this from here up to there is going to be my f of g of x. Normally, some textbooks, they write this like that. They add another bracket showing that this function is now fed into the function of f of x. So the calculations that we're going to be doing are going to get us functions, but this is how it normally looks like. We have a domain. The domain first gives us the first image. Then the first image acts as the object to the next function that transforms them to the last images. That is the last range there. Now, there is also another function. Remember, we talked about the inverse. So this one that sends this back here, sends these images back to the original objects. It becomes the inverse, f of g inverse of x, like that. So this is what we're going to talk about. This one we cannot talk about so much, but you can easily find out the inverse if you have this. Remember the steps which we talked about in the last lesson, where we looked at the inverse. Then this one here, we are going to see from our first example that this one here is not the same as the G of f of x. It is not the same. You're going to see how we mean by that. This one means that the first function here was meant to be f of x, and then the last function to transform there was supposed to be G of whatever is there. So solution for the first part there, it is going to be all about substitution. Remember, in our first lesson, or the second lesson, we are given a function f of, let me say, x squared plus 1 all over x, and then they tell you to find f of, let me say, negative 3, and you tapped this, you substituted this here, negative 3 squared plus 1 all over the negative 3. So it's all about substitution. This is what we are going to be doing also here. You get your function of d of x, then you substitute it into the function of f of x. This is what we're going to be doing. Again, even here, if they tell you to find f of a plus b, that is where there's x, you're going to put now a plus b. So that is a plus b squared, then plus 1 all over a plus b. So it is all about substitution. Remove x, you punch in what is there. So my f of g of x, I'm going to first ask myself, what is my g of x? My g of x is now x plus 2, right? So I'm going to substitute this where there is my f of x. My f of x was given as x squared plus 4. Now, what is here now is the x plus 2. It is no longer now the x. This is what I was saying. It's all about substitution. So I'm going to substitute this in there. So this is going to be x plus 2. The x there was squared. And then there is also an addition of 4. You can simplify by expanding this. The square means bracket times bracket. That is it. The square means bracket times bracket. Then I'm going to start opening the bracket. This is x into that one there is x plus 2. Then the plus 2 into the x plus 2. Then plus 4. So when I open here, it's going to be x squared plus this times that 2x. When I open here, this is 2x. 2 times 2 is a 4, then a plus 4. That's why I was opening brackets such that I can add these like terms. So this is going to be x squared plus 4x, then plus 8 as my f of g of x. Now, part B, you're being asked the g of f of x. So I've said this one here, I'm going to first substitute that one there. So this is my g. This function here was x squared plus 4. Then I asked myself, what was my g of x? The g of x was x plus 2. So you can see now, this, I'm going to substitute it for x in there. So this becomes x squared plus 4. Then there is an addition of the 2. My g of f of x now gives me x squared then plus 6. I think now when you look at these two here, they are totally different. They are not the same. Then now we need to find part C and part D. So part C, they are telling me to get the g of f of 1. Now I'm having my g of f of x, so I need just to substitute. I'm going to just substitute where there is x there. So this is going to be 1 squared plus 6. So the 1 squared is 1 plus 6. That's going to give me 7 as my g of f of 1. Then part D, they are telling me to find the f of g of 1. I need to substitute here 1 wherever there is x there. So my f of g of 1 is going to be equal to 1 squared plus 4 times 1, then plus 8. 1 squared is 1, plus 4 is 5, plus 8 is equal to 13. And this is the 13 when you go back to the introduction of example 1. This is the 13 we last got here down. It was somewhere there down in the last range there. Example 2, if h of x is equal to x squared plus 1 and g of x is equal to 2 all over x plus 1, find Roman 1, the g of h of x, then Roman 2, h of g of x. Just like in the first example, the g of h of x. So my g of h is going to be equal to, I'm going to substitute this one here, x squared plus 1. Then I'm going to feed this, substitute it for x there. So this is going to be the 2 all over x squared plus 1. Then that one also had the 1. So this x squared plus 1 has taken up the value of all the place of x there. So when I add these like terms, this is going to be 2 all over x squared plus a 2, and this gives me the g of h of x. Sometimes some people like to use this if wants to find that one there. What he does, he gets, he substitutes this, the f of h, 2 all over h of x plus 1, because it is immediately the one which has been there, and it is substituting for the value of x in the function of g of x. Then he asks himself that what is this function here? The function was given as the 2 all over x squared plus 1, then also the plus 1. Then finally to get 2 all over x squared plus 2, which is the same as this. So Roman 2, the h of g of x. What is my g of x? The g of x is 2 all over x plus 1. Now I'm going to substitute it in here. My h of x in the question was given as x squared plus 1. So I'm going to get the whole of this to substitute the place of x there. So this is going to be 2 all over x plus 1 squared. Then there's a plus 1 there as my h of g of x. You can simplify, but it will take us more steps. Only that to remember, just to make you remember, those of indices, the 2 is going to be squared, and also the denominator is going to be squared, then plus 1. Then 2 squared is a 4. The LCM of 1 and 1 is the x plus 1 squared. Then you expand this one here. It is going to be a long, but you can stop there if you have not told us to simplify further, because here there is going to be a 1 which will add to this one to have a 5, then plus x squared plus the 2x, then divided by the x plus 1, then in brackets squared. So the final simplification to be that one there. So our example 3, given that the h of x is equal to x squared all over 2 plus 1, f of x is equal to 3x, find the value of x for which the h of f of x is equal to the f of h of x. So even here, you can apply the composite functions and we find the values of the unknowns. So the lead is there in order to find the value of x. So it's what I'm going to begin with, the f of the h of f of x is equal to the f of h of x. Then now I'm going to first get these functions, these two functions here. So we say this is going to be h. What is the f of x? Is 3x. It give me f. What is h of x? It is x squared all over 2 plus 1. Then now I'm going to substitute this 3x in the function of h of x. So my h of x is there. So where there is x, I'm going to put the 3x. So that is 3x. The x there was squared, then being divided by 2. Then there was an addition of 1. And then I'm going to substitute this in the function of f of what? Of x. F of x is 3x. So the 3 into the x squared all over 2, then plus 1. So when I square here, laws of indices, whatever is inside the bracket is going to be squared. So 3 squared is 9, x squared is x squared, then divide by 2, then plus 1 is equal to this side. When I open the bracket, that's going to be 3x squared all over 2, then plus 3 times 1, which is 3. Now I'm going to you can either collect like terms, yeah, take this the other side, right, and then simplify, or get the LCM of all the denominators and then I multiply it throughout. So the LCM here of 2 and 1 is 2. So I'm going to get 2 times 9 x squared divided by 2, then plus 2 times 1 divided by 1 is equal to 3, is equal to 2 times 3x squared divided by 2, then plus 2 times 3 divided by 1. Then here the 2 is going to cancel. Then I remain with the 9x squared. Then here it's going to be a 2. It's equal to. Then here the 2 is going to cancel. And then I remain with 3x squared. Then here, this one here, it's going to be positive 6. Then now I collect like terms. I'm going to take this side and then the positive 2 the other side. So this is going to be 9x squared. The 3x squared has been positive, now takes up the negative. Then 6 has been positive. The 2 here has been positive. Then this one here is going to be a minus. When I subtract here, I'm going to have 6x squared is equal to a 4 the other side. Then I divide both sides by 6 and that will be 6. So this is going to be x squared is equal to 4 all over 6. Then now I can take the square root both sides. Square root that way, square root that way. So this is going to be x is equal to plus or minus the square root of, when I simplify here, this is going to be 2 all over 3. So those are the two values of x. You can either place the calculator and you get these values and you write them to 2 decimal places, or you can leave it like that. So example 4 there, given the functions h of x there, and then the g of x there, find the g of h of -2. Now this one here, we have two alternatives. One is to first find the function of the g of h of x, or we can first get h of -2, then finally we get the g of the result of h of -2. So my h of x is equal to 2 all over the x plus 3. So when I try to get the negative, h of negative 2, this is going to be 2 all over negative 2 plus 3. I've substituted for x the negative 2. Then this is going to be a 2 divided by 1, which is a 2. So my h of negative 2 is now a 2. The question wanted the g of h of negative 2. But now I've already got this g, this h of negative 2. So now it is g of, instead of h of negative 2, I'm going now to put there 2. Then I substitute this 2 into the function of g of x. So the g of x was given as 4x, so that's going to be 4 into 2, and this one here is going to give me 8. So I can get that. Why using this? Because initially they did not ask for the function of g of h of x. So alternatively, someone can first find the function g of h of x, and this one is g. The h of x is the 2 all over x plus 3. And when I substitute this in there, this is going to be 4 into the 2 all over x plus 3. The 4 is all over 1. Now the function becomes numerator times numerator. That's going to be 8 all over 8 plus 3 as my g of h of x. Now going to this to find the g of h of negative 2. Now this is going to be 8 all over the negative 2, and then the plus 3. So down here I get a 1. 8 divided by 1, that's going to be 8 as my g of h of negative 2 as initially here.